The last reaction we're going to talk about now is nuclear fusion. What basically happens is if fission is breaking apart of elements, nuclear fusion is the elements combining together to form heavier elements. So a targeted nuclear absorbs an accelerated particle. The nucleus may or may not break down at this point. So the most obvious example I can think of is the sun, where we've got a hydrogen particle and another hydrogen particle formed together to form a helium, and a neutron shoots off. This happens all the time with the sun, which is why we have sunlight and energy. These reactions require excessive temperatures to start, but generate massive amount of energy in the form of radiation and heat. So for you to try an example of a nuclear reaction or nuclear fusion question, if we've got 252.96 californium, and we add in 10 boron, the resulting particle that's fused together is 257.101 mendelevium. Try to figure out how many neutrons are released. If we take a look here, we know the mass of californium is 252. We know the mass of boron is 10. So we know this whole reactant side has a mass of 262. We know the mass of this side should be 262. We know the mass of mendelevium is 257. And that is equal to 5. So therefore, there has to be 5 neutrons available in order for this reaction to occur. One more example to try. If we've got 6,3 lithium, and we fuse it with a hydrogen particle, the end result is we're going to get 2 somethings. What are those somethings? So if we take a look at the mass here, we know the mass of this side is 6 plus 2. So that's equal to 8. So we know the mass for both of them has to be 8. But since there's 2 particles, we know the mass has to be equal to 4. In terms of the number of protons, we know lithium has 3 protons and hydrogen has 1 proton, which means between the 2 particles, it has to have 4 protons. Divided evenly, that gives it 2 protons. 4, 2 is helium, or an alpha particle.